Hello and good morning, grade 9 with you, Mr. Samir Awad. And today we are going to start chapter 5, lesson 1, revising the atomic model. And today we are going to start by part 1. First here, why do scientists use mathematical models to describe the position of the electrons in the atom? Shown here is a life-size model of a sphere, but not all models are physical here. In fact, the current model of the atom is a mathematical model. So here we talk about the energy levels in the atoms. And here what did Bohr propose in this model of atom? So Niels Bohr here is going to get some limitations and some deficiencies that happen in the Rutherford model about the atom itself. So here you are some of the limitations of Rutherford atomic model. In the beginning, Rutherford explained only a few simple properties of the atom, and he didn't explain all of the properties, and that's the deficiency. And also, it could not explain the chemical properties of elements, and that's another one. And also, he cannot explain or illustrate what happened for the iron when it started to be heated. It started to get the red dot color, and after that turns into yellow, and after that, when it's heated more and more and more, it starts to be white color. And that's what happened with some elements and compounds that contain metals when they make the flame test. So the Bohr model here, guys, in 1913, yeah, Niels Bohr started as a young Danish physicist, yeah, who was one of the students of Rutherford himself, developed a new atomic model. He changed Rutherford's model to incorporate newer discoveries about how the energy of an atom changes when atom absorbs or emits light. So Bohr proposed that an electron is found only in a specific circular path or orbit around the nucleus. And each possible electron orbit in Bohr's model has fixed energy. The fixed energies of an electron can have are called energy levels. So here we have energy levels or orbits for the electrons. They can only get to be there in this part. And he said also, each possible electron orbits in Bohr's model has a fixed energy, and the fixed energies of the electrons can be called energy levels, and the quantum of energy or the amount of energy, yeah, so the quantum of energy or amount of energy required to move electron from a level into another one is supposed to call the quantum. So the ranges on this ladder are somewhat like the energy levels in Bohr's model of atom. A person on the ladder cannot stand between the rungs. Similarly, the electrons in the atom, they cannot exist here, guys. As you can see the arrow, they cannot exist here in this space, yeah, because it's prohibited to be here. But you can to be here as an electron in this level, or move to that level, or to that level. But you have to be on the ranges, not between them. And that's what was there. And the energy levels of the atoms are not equally, as you can see here, the ladders are not getting, yeah, equal spaces between them. Yeah, in the beginning start the gap to be far away, so the energy required will be more. But when you get to the nearest, yeah, the outermost levels will get them to be near in the energy from each atom and closer together. So how does the Bohr model improve upon the Rutherford model? You will see why Happen. Rutherford model couldn't explain why elements that have been heated to higher and higher temperatures give off different colors of light. And Bohr's model explains that how energy levels of electrons in an atom change when the atom emits light, and that's happened when it gets amount of energy or quantum. So we'll get here the quantum mechanical model, and that's another one. So that's we are getting to compare between it and Bohr's. So that is going to upgrade more and more guys to know more about the electrons and how they start to behave inside the atom itself. So here, what does the quantum mechanical model determine about the electrons in the atom? And here we'll get the Austrian physicist Erwin Schrödinger, who got the theoretical experimental calculation for the quantum mechanical model, and that's describing the behavior of the electrons in the hydrogen atom by mathematical equation to be more and more specific about it. Like Bohr, the model of the quantum mechanical model of atom restricts the energy of electrons to certain value. So we must get the energy to be restricted there. And unlike Bohr's model, however, the quantum mechanical model does not specify an exact path of electron takes around the nucleus. So there is no orbit in the new mechanical quantum mechanical model here. Yeah, there will be another thing is called electron cloud, not orbit that or fixed orbit or fixed circle that the electron is going to evolve around the nucleus in it. So the quantum mechanical model determines the allowed energies of an electron can have and how likely it is to find the electron in various locations around the nucleus. So probability was the solution for that. Probability describes how likely it is to find electron in particular location around the nucleus. So in the quantum mechanical model, guys, the probability of finding an electron within a certain volume of space around or surrounding the nucleus can be represented by a phase cloud-like region, like you can see here. So if the electron is going to be here or here or here, it's in the electron cloud around the nucleus. And when the probability gets higher, that means that we have something is called orbital, and we'll say it after. So the cloud is more dense where the probability of finding electron is high. And how are the quantum mechanical model and Bohr's model alike and how they are different? We can say that like the Bohr's model, yeah, the quantum mechanical model restricts the energy of electrons to certain values. Yeah, and unlike it, you will get the quantum mechanical model does not specify an exact path for electrons like Bohr. Yeah, but they get another definition is called, yeah, the electron cloud, and it depends on the probability of finding the electron around the nucleus. Yeah. Next time, guys, we'll start to work on part two. Thank you for listening. Yeah, and good luck. Be safe at home.